So now that we've reviewed the fundamental counting principle, let's now take a look at what a permutation is. So a permutation is going to be any ordered arrangement of a given set of objects. So the key thing about a permutation is order matters. So let's take a look at an example. So suppose Al, Betty, Carl, and Dan are in a club, and the club needs to elect a president and a treasurer. Now, order is going to be important, right? It matters who is the president and it matters who is the treasurer, and repetitions are not allowed. So the same person can't be in both spots. So the question is, how many ways are there to elect two people in which one person is the president and one person is the treasurer? So let's represent this in a tree diagram. I'm going to have the president and I'm going to have a treasurer. All right, so for the president, what could happen? So it could be Al, Betty, Carl, or Dan. Any one of those four people could be president. Let's assume Al is the president. Then who could be the treasurer? Well, it could be Betty, Carl, or Dan, right? So Al can't be the treasurer at that point because he was elected the president, so and then I would have three options here. What if Betty was the president? So then it would be Al could be the treasurer, or Carl, or Dan. What if Carl was the president? So then it would be Al could be the treasurer, Betty, or Dan. And running out a little bit of room here, but we'll squish this in here. If Dan is the president, it could be Al, Betty, or Carl. So the key thing on this one when we say that it's an ordered arrangement is this one is considered to be A, B, and this one is considered to be B, A, and they are different. Okay, so this is going to be a different ordered arrangement. We're just saying it matters who is listed first versus who is listed second. So how many ways is there to elect two people in which one person is the president and one person is the treasurer? Well, one approach, the one we kind of have already talked about in this course, is you could say, all right, there's four people that could be the president, pick them. Now there's only 3 people left to be the treasurer, so there are 12 possible ways. And we're seeing those 12 in our tree diagram. That's one approach to solving this problem. Another approach will be using this idea that this is a permutation. This is going to be an ordered arrangement of a given set of objects. So we can use a different computation to be able to figure out how many ways this could happen. So before we get down to our permutation formula, we need to talk about what a factorial is. So n factorial, which is symbolized with n with a exclamation point after that, represents the multiplication of the number you're seeing right here, and then you're going to count down all the way to 1. And then we define 0 factorial to be equal to 1. So illustrate this with an example. Let's evaluate 5 factorial. So 5 factorial, which is going to be equal to 5 times 4 times 3 times 2 times 1. You go to plop all that in your calculator. 5 factorial is 120. Now, there is a factorial key on your calculator because, for instance, let's say this had been like 10 factorial. We wouldn't necessarily want to sit there and key in 10 times 9 times 8 times 7 times 6. That's starting to get into a little bit excessive key presses. And factorials actually occur quite a bit in various calculations. So the factorial key on your calculator, now, depending on what calculator you have, a scientific calculator will have it somewhere. I'm going to talk about where this is on a TI-84 graphing calculator, so I'm going to go ahead and bring mine up. So a factorial will be, if you go inside math, which is over here on the left-hand side, you'll have different menus up here. So you have a math menu, number, complex, and then probability. If you arrow over to the probability menu, there's your factorial option right there. So that would be option 4. So what you would need to do then, so I'm going to quit out of here. So you would first key in what you want your number to be, and then you would go inside math. Now I'm just going to arrow to the left to kind of swing back around here. Then you could either arrow down to the 4 and hit enter, or you could actually hit the number 4 to grab it. So now that I have that symbol on here, I'm just going to hit enter to evaluate it, and there's your 120. Okay, so you should know where the factorial key is on your calculator to help you evaluate some of the stuff we're going to be doing in the next few sections. Okay, so if you don't have this type of calculator, you might need to go to your calculator's instruction manual to find out where the factorial option is on your calculator. Alright, so the permutation formula will involve factorials. So for this formula, let's kind of just break down what we're seeing here first. So this P stands for permutation. In the next section, we're going to have a big old C right here for combination. But this section is all going to be about permutations. This number right here that you would write to the lower left of the P. So the value that sits right here for where in this symbolic notation has N. N is equal to the total number of objects that you have to pick from. This number right here, R, which would be written to the lower right of this capital P, this R right here, is how many objects you want for your set. So what the formula then would be then to compute this, it would be n factorial in your numerator, and then in your denominator it would be n minus r. You do that subtraction first, and then you apply the factorial. Okay, so let's see how that relates to this scenario with these people being elected. So order is important, which is why this is going to be a permutation. Okay, so I put a big old P for a permutation. To the lower left, I'm going to write how many people there are to even pick from. So there are 4 people available, Al, Betty, Carl, and Dan. And then how many of them do I want for my actual election? Is I would want to fill 2 spots. So that would be the value for R, which I would write to my lower right. So then what this formula says to do then, to compute this, is it would be then the value that you have written in front here, you're going to do that value and then factorial. So in this case it would be 4 factorial. And then in the denominator, you're going to take these 2 numbers and then you're going to subtract them and then apply the factorial to that difference. So then this would be 4 factorial over 2 factorial. Now you have to be a little bit careful when working with factorials in terms of what simplifies. So the easiest way to sometimes do it is just to write out by definition what the factorial represents. So 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1. Now we can see what sort of simplifying we can do. Okay, so then after I'm done simplifying, I'm left with 4 times 3, which is 12. So the same answer, a slightly different approach to it. Okay, so either one of us gets us the number of ways. There was the fill, the president, and the treasurer. The 2 different approaches, you should be able to recognize when a scenario involves a permutation, and some of your answers might ask you just to leave your final answer in the symbolic notation, not actually evaluate it. And some of your answers might ask you to show me how to use this formula to simplify it. Okay, so just to kind of have one final say about the permutation formula before we start getting into some additional examples. So this one down here, it says use a factorial key on your calculator to compute 100 factorial divided by 98 factorial, and what happens and why. So let's go ahead and plop that into our calculator. So in our calculator, I'm going to do 100, and then go inside Math, grab my factorial, divide by 98, go inside Math, grab my factorial, and then hit Enter to evaluate it. Alright, so what happens? It looks like I got an error overflow. So I'm just going to quit to exit out of there. Alright, so what happens? We got an overflow error. Now, why would that happen? These are huge numbers. Right, so your calculator, wait, I can't compute that for you. Okay, 100 factorial. So let's go to part B. Without using your calculator, use the definition of factorials to compute this. We can compute this by hand fairly easily. Your calculator is definitely overthinking this. 100 factorial over 98 factorial. Alright, so 100 factorial. That is 100 times 99 times 98 times 97 times 96, and I don't feel like writing anymore, so this all would go all the way down to 1. Okay, so this is a huge number. Let's see what's happening downstairs. Downstairs is 98 factorial, so that would be 98 times 97 times 96, and then that would be all the way down to 1. It's multiplication all the way through, so anything we're saying both upstairs and downstairs we can simplify. So these will simplify, these can simplify, and then all the way down to the 2 times 1 can simplify. So what am I left with? The 100 times the 99. Well, that's pretty straightforward. We can compute that without a calculator. Okay, so for the factorials, once you kind of have them expanded out, you can see what sorts of simplifying you can do. Now for part C, how does this above expression connect to the permutation formula? And then we're going to use our permutation key in our calculator to compute it. So this expression, well, that relates to this. 98 is 100 minus 2. Now, the key thing of why I wanted to do it like that is because I was trying to utilize the same number to connect it back to this permutation formula. So the 100 is acting like my n, and the 2 is acting like my r. So then this is going to be equivalent to the permutation of 100 objects where you want to choose 2 of them. Right, so for this permutation then, it says use the permutation key in your calculator. So notice it didn't say factorial key. Your calculator also should have a permutation option. So in my calculator, it is right next to where we pull the factorial. So how I key this into my calculator is first I have to enter in what I want my value to for n to be, which would be the 100. So I'm going to go inside Math and then back inside that probability menu, and then option 2 is my permutation key. So you can either arrow down to that to select it, or I could just hit the number 2 to grab it. And then now I need to key in what I want my r to be. So I want my r in this case to be 2. So the key thing on these ones is you just have to be very careful that you key in the value for n before you grab your the calculator function. So if I go ahead and hit enter, right, so at this point in time, now the calculator can see a little bit better about what's going on, and it knows how to do the simplifying to pull your final answer. So in this case then, in my calculator, it gave me my 9900. Okay. So you might want to write yourself a note just to remember where these things are. The factorial in my calculator was inside math, and then we had to arrow over to the PRB menu, and then it was option 4. So maybe I'll put that in brackets, so that was an actual button I had to press. That was supposed to be a B. For my permutation key, that again is in math. You would arrow over to the PRB menu, and that was option 2.